true that we don't have school Valentine's Day or the next Monday?
I thought you
Four-day
had
weekend?
school Valentine's Day.
Oh, we talked about this the other day, didn't we?
Yeah, and it was like our things said different things, and they're both school calendar.
Yeah, but I think so. The week after Valentine's Day is Winterfest, and so we always do a Pep Fest on the Friday before that week, and we can't because admin told us we had to do it on Thursday. So I would
Push it back a
assume
week.
there's no school Friday,
It's a long week.
but there also isn't school Monday.
Wow. No school on Valentine's Day? I think there's a law against that. I think you have to have school on Valentine's Day.
Think about. I wonder if you do.
Is
yeah.
Valentine's Day on the same?
If you
Is it on the
wait,
same
can
day
you
every
take
year, or is it?
can you take
Oh.
teacher prep days off? Like
Um,
be sick?
Yeah, you could use a sick day. Yeah.
Because I feel like you and your wife could have a really good date.
I think that's a good idea.
Okay.
Might schedule that one. So what happens is every year I get a certain number of sick days to use. Say I get like 12.
Yeah.
And if you don't use them, they carry on over the next year. So the next year at
Oh.
24.
Because then you
Next
can use
year
it for
36.
vacation.
How many are you at right now?
I'm at like
Oh, you did that.
153.
Holy cow! Just take a year off.
But
Take
then-
next year off.
Yeah, take the
But
whole
then-
half of the semester off.
But they cap at a certain point. Like I
Oh.
You
can't
gotta start using
I
those.
can't
dude.
accumulate beyond 100.
Can you use them like for vacation?
You gotta start using those prep days, like as sick days.
So technically, you like if you use it for illness, like they could say, okay, you need to produce a doctor's note. You know what I mean?
Oh.
But they haven't gone that far. But technically, that's kind of how it is. Every once in a while, people take a mental health day. I don't know. My job's not too tough, but no, I would enjoy a day off. I've been thinking about it. My daughter has surgery on her hip on January 24th. So Tenley, the little 8th grader, she got surgery on the 24th. So I got to take a day then. So we'll have to figure out what to do. Ethan will teach class.
Let's go, Ethan.
I'll try my best.
Honestly, I sometimes worry that if I'm gone, I worry how many people will choose to show up to school then. You know what I mean?
You need to take a mental health.
Like if I'm not here that Friday, like I know Mika already said I ain't showing up if Gens is not here.
Yep.
So, but anyway, so we'll
This is
see.
the only class you're here for, right?
Yep.
Yeah. I wouldn't either.
Yeah, I don't blame you. Calculus is about 3 big ideas. Number 1, it's about derivatives, which you guys need your driver's licenses.
Yeah.
Oh,
when
I
do you
got
get
I
those? When do you
know,
get
I know,
those?
I know. I got like a list right now. I'm like, just can't do it. It's also about integrals, which you don't know. You are like we start integrals next week Tuesday, so we'll be ready to kind of get in the next piece. And then finally, calculus is about limits.
Are integrals hard?
No big deal.
Alright. Okay, I think you're lying.
No, it's all good. It's all good. Third quarter's it's just bliss. It's all fun.
He's
So
lying.
so anyway, there's this guy named L'Hopital. This is all about limits. Okay, all about limits. And he was trying to consider some really, really challenging limits. Okay. Now, for example, I'll just throw one up on the board for you guys to kind of just think about for a second. Suppose you had this, and I think you hopefully remember that you already know the answer. The limit as theta goes to 0 of sine of theta over theta. Do you remember what that was?
1.
It is 1, yeah. It is 1. We actually proved that one day. We used up a lot of space on the board. It took a really long time. But what's interesting about this is if you plug in 0, you get 0 over 0. So L'Hopital is like, what happens if you get that indeterminate value? Similarly, he said, well, what about this? What if you had the limit as x goes to infinity of x squared plus 1 over x cubed plus 1? Do you agree that the top is infinity and the bottom is infinity?
Mm-hmm.
Yeah, we actually worked at kind of trying to figure those out too. Like, how do you do infinity over infinity or 0 over 0? There's different levels of infinity, different levels of 0. How do we handle that? And he came up with a really cool way of navigating these problems. This is like our last application piece of derivatives for the rest of the year. And he said, given you have the following conditions, suppose that the limit as x goes to something of f of x over g of x. So the condition is that you have a quotient. You have something on the top and you have something on the bottom. Okay? So limit is x goes to a of f of x over g of x. Suppose you get 0 over 0. Or suppose you get infinity over infinity. Okay? And we're like, what is that? Like, how do we compute that? L'Hopital said that the limit is actually calculated by looking at the rate of change of each one. So the limit as x goes to a in that scenario of f of x over g of x is equal to the limit as x goes to a of f prime of x over g prime of x. But the initial condition must be met. We first must get 0 over 0 or infinity over infinity. That's what we must start with, okay? If you get a crazy scenario like that, you can apply L'Hopital's rule. It's a really, really handy way of figuring it out. Now, just to kind of show you how simply this can work out, look at this example right here. The limit as theta goes to 0 of sine of theta over theta, we get 0 over 0. So Ben memorized that it was 1. Suppose that you hadn't memorized that it was 1. You could take the derivative of the top. What's the derivative of the top? Cosine. And what's the derivative of theta? 1. And so now you can plug in 0. What's the cosine of 0? Cosine of 0 is 1. So you get 1 over 1, which is 1. So L'Hopital's rule works really, 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 really well. Now, I gave you guys a different function here because I didn't like this one. What did I give you guys?
X squared minus 1.
X squared minus 1 over x minus 1. So if you were to plug in, oh my gosh, did I really give you guys x goes to 0? It's
No, you
x.
gave us x goes to equals.
Yeah.
Yeah, we have x goes to equals.
Oh gosh. So what was supposed to happen in there is it just got cut off. The font was too small. It's supposed to be x goes to infinity. Okay. It's supposed to be x goes to infinity. Okay. So this is my best way to kind of give you some type of graphical explanation of why this works. Okay. If we have x squared minus 1 over x minus 1, and we were to look at this, okay, at what this is, the x squared minus 1 is a parabola that looks like that, right? And if you look at x minus 1, that's a line that looks like this. And so what we're going to compare is we're dividing them. So we're going to look at the difference between the two. Everybody agree that although the blue and the green are not the same here, they're pretty close. And if you divide two things that are pretty close, you're going to get 1, right? But as you continue to move on, does everybody agree that the distance between the blue and the green, that continues to get larger and larger and larger? Yeah. So if you look at this distance here, you know, it's a little bit larger, a lot larger, a lot larger. As you continue to go on, it continues to get larger and larger and larger. So the distance is heading towards infinity, okay? And so as you consider that, if we would use L'Hopital's rule to try to figure this out, notice if you plug in infinity, you get infinity in the top and you get infinity in the bottom. Like, oh, well, I don't know what that is. And I forgot how to factor out the x squared out of the top and factor the x out of the bottom. You guys remember when we did that first semester? Factor the x squared out of the top, factor the x out of the bottom. You say, let's just use L'Hopital's rule. Limit as x goes to infinity of, what's the derivative of the top? 2x. What's the derivative of the bottom? 1. So now you plug in infinity and just get infinity. So in that situation, infinity divided by infinity is infinity.
So that's the answer?
That's the answer. Let's try example 2. We must verify that the condition stands at the very beginning, that you get a 0 over 0 or an infinity over infinity. And so here we plug in 1. We have the limit as x goes to 1 of the natural log of x divided by 1 minus x, which is, if I plug in 1 to the bottom, obviously I get 0. Does anybody remember what the natural log of 1 is?
Zero.
Probably about 1.
Yep, according to the graph, you know it goes through that coordinate, therefore the natural log of 1 outputs 0, so I get 0 over 0.
So then we know we can use the rule.
So now we can use the rule. The first time I ever taught this, I didn't say that you had to first verify that. Some people were just using it all the time, and we're getting all these wrong answers. Like, what's going on? If you don't have 0, 0 or infinity, then you can't use the rule. So we take the derivative of the top. What's the derivative of natural log of x? 1 over x. What's the derivative of the bottom? Negative 1. So now we plug in 1, and we get 1 on the top, and we get negative 1 on the bottom, so the answer is negative 1. Pretty nice, huh?
Mm-hmm.
Flip it over.
Do we have a different homework assignment?
So, because you're all on homework, aren't you?
Yeah.
Yeah, so I forgot to run off the worksheet, so we'll just staple that onto your.
Oh.
Yep. So now we have the limit as x goes infinity of e to the x over x squared. And so I plug in infinity. E to the infinity is going to give me infinity. It's going to be very large. And infinity squared is going to be infinity. So this is a prime condition to use L'Hopital's rule. So I take the derivative of the top, which is?
E to the x.
Take the derivative of the bottom, which is?
2x.
And now I plug in infinity. E to the infinity is going to be infinity, and 2 times infinity is infinity as well. Uh-oh.
Can you do it again?
So you do it again. Limit as x goes to infinity of, the derivative of e to the x is e to the x, and the derivative of 2x is 2. And infinity divided by 2, although it is smaller than infinity, it is still infinity.
See, like that's so weird.
Big number.
The next one, natural log. Sometimes people wonder about, what do you do this whole natural log business, or say the cube root of x. I find this really interesting because if you consider the graphs, they do head off to infinity, but they head off at a very, very, very slow rate. So for example, the cube root of x looks something like that. Everybody agreed? So as x goes towards infinity, y does continue to go up, but a lot slower than the other ones, doesn't it? And natural log, like that heads off really slow, even slower than x to the 1/3 power. So, but what happens if we were to divide those two? Well, first you can see that if we plug in infinity, although it goes very slow, we do have infinity, and the cube root of infinity, we still have infinity. So I need to take the derivative of the top. Anybody, how do I take the derivative of the natural log of 2x?
Chain rule.
Chain rule. So I have the natural log of u, and I have 2x. The derivative of natural log of u is 1 over u, and the derivative of 2x is 2. So I get 2 over 2x, which is just, the limit as x goes infinity of 1 over x over, and then the derivative of cube root of x, or the derivative of x to the 1/3.
One over 3.
1 over 3, x to the
Second.
2/3. Yep, good. You're right, second, there you go.
Yeah.
And now we must multiply by the reciprocal. So I multiply by 3x to the 2/3 over 1. And I have the limit as x goes to infinity of, well, I'm going to have a 3 in the top, but everybody agree that 2/3 is less than 1? So I'm going to have what in the denominator?
Cube root of x.
X to the 1/3 or cube root of x. So now, as we plug in infinity, we get 3 over infinity. Uh-oh, what happens if you have 3 over infinity. A number over a very, very large number
Zero.
can produce 0. Let's see if this next one gives us the condition that we are looking for. We have the limit as x goes to 0 of, we have 0 minus the sign of 0 is
0.
0 over 3 times 0 squared is 0. So I do get 0 over 0. So I must confirm I get that first. The derivative of the top.
One
1 minus
cosine of X.
cosine.
Good. Over
6.
6x. We plug in 0. What's the cosine of 0?
1.
0.
Cosine of 0 is 1 because, consider the unit circle, that spot right there is 1, 0, and cosine is the x value.
Okay.
So we have 1 minus 1 is 0, and maybe that's the 0 you're referring to. And then the bottom 6 times 0 is 0. So we do it again. Limit as x goes to 0 of, the derivative of 1 is 0. What's the derivative of negative cosine?
Sine.
Positive sine. Divided by 6. What is the sine of 0?
0.
0 over 6. So we get 0.
So we can't get 0 over 0?
So 0 over 0 allows for L'Hopital's rule. Infinity over infinity allows for L'Hopital's rule. They're both what we call indeterminate values.
Okay.
Indeterminate values. See if you can come up with the initial condition on number 6. See what you come up with by just plugging in pi. About 30 seconds, see what you get.
So if the side is 0, how is it 0?
Oh, yeah.
Because
So
it's
it's negative.
or no?
Right here.
Well, sine.
So sine of 0 is 0.
It's 0. It's on the other side.
6 is 6.
It's
Unit
negative
circle.
1, 0, so it's a sine and it's 0. The point
You look
is-
at the unit circle.
Yeah.
And
You have
sine
sine
is
is
the
the y value.
Yeah. Oh.
So for a 0 degrees, you have
And then
0 is the y
negative.
value. Better? What is the sine of pi?
0.
0.
What's the cosine of pi?
-1.
Negative 1. So 1 minus negative 1 is 2. So you get 0 over 2. So does L'Hopital's rule apply?
No.
No. The answer is just 0 because 0 divided by 2 is 0. So I don't have to use L'Hopital's rule.
Boom.
If you did try L'Hopital's rule, it would be incorrect. This one right here, we had a tricky way of solving this before. I taught you first semester by factoring. But who wants to do all that factoring, right?
Right.
It's actually easier to use calculus than it is to factor. Think about that for a second. That's pretty impressive. We plug in 1 and we get 14 minus 14 over 6 minus 6, or 0 over 0. Uh-oh. L'Hopital's rule. Limit as x goes to 1 of, what is the derivative of 14x to the 5th?
70x to the 4th.
And the derivative of 14 is?
0.
0. Now at the bottom we have 24, x to the 3rd. I plug in 1 and I get 70 over 24. Divide the top and bottom by 2 and I get 35 over 12. Take out your calculator. We're going to use it for both this one as well as the next one. I want you to type in that function 14x to the 5th minus 14. Make sure you put parentheses in the top. And when you get that, I want you to first do zoom 6. Whoop. And then after you zoom 6, I'd like you to follow up with zoom as a decimal. So zoom number 4. Oh, got 6 on the end there. That's my problem. Okay, we got what I got? Notice that when you look at this here, you get 35 over 12, which everybody agree that that's almost 3? Almost 3. And if you check this right here, you press trace, and you look at the value that you have right here, as x approaches 1, okay? Notice we have this piece that's missing there, and sure enough, just over 3, just under 3. And so it does confirm exactly with what you want algebraically, and notice how that spot is missing, just like we saw before. But sure enough, that can calculate exactly what we want. Our last example, we're going to need our calculator for this. We have limit as t goes to 0 of e to the t minus 1 over t cubed. Really like this example. What is e to the 0?
1.
And 1 minus 1 is?
0.
So I get 0 over 0. Is that a condition by which we can use L'Hopital's rule?
Yes.
It is. So we go ahead and we say the limit as t goes to 0 of, what's in the top? And what's in the bottom?
3t squared.
Excellent. So we have e to the t over 3t squared. What is e to the 0?
1.
Divided by the bottom?
0.
0. Is that a condition for L'Hopital's rule? No. Now, in this case, many people would say that this answer is undefined. And although we may think of this as undefined in the normal kind of calculation world in terms of arbitrary numbers, the fact is when we have an expression that we can think about ahead of it, the answer might not be undefined. In fact, a limit is usually always a specific number or infinity or does not exist, but we generally don't think about undefined. And so I want to help you think through this. It's not too difficult, and this is a valuable step for you to move forward as you try to think analytically. Do you remember what the graph of e to the t looks like? What does the graph of e to the x look like? An exponential function. Good. Archie's got it. He says it starts low and it heads up like that. Everybody good with that? Okay. And now I'm going to graph the next one, 3t squared. What does that look like? Yeah, a whoosh parabola. Good. Got a whoosh parabola right here. Excellent. So I want you to consider what's happening as we approach 0. And we're going to approach 0 both from the left and from the right. Okay, we're going to approach it both ways. Okay, watch what I have here. As I approach e to the t from the left, as I approach 0, what is the output approach?
1.
1. What does the bottom approach?
0.
0. A really small number, right?
Mm-hmm.
I'm going to write small positive number. Everybody agreed?
Yeah.
Now, let's approach the other way. I'm going to do the red function approach from the right here.
1.
And I definitely approach 1. And then as I approach the other way, I also come to a small positive number. So if you take 1 and divide it by a really small positive number, what kind of number are you going to get?
Big number.
Yeah. And notice how it's the same there?
Yeah.
So in this situation, it's not that the limit doesn't exist. The limit does exist. In fact, it is infinity. We can't really see that. L'Hopital's rule doesn't have help for us there. We can only think about it by looking at the graphs and considering it analytically. And if we typed that in our calculator, we looked at our tables, that's exactly what we would find. Good. L'Hopital's rule, review of derivatives. Your last lesson before we kind of set derivatives behind us for quite a while. You can take and staple this to the back of your other worksheets.
Oh.
Do you have anything else this week of great importance other than this test on Friday? Do you have other papers or big assignments, projects, anything building up?
Anatomy test.
Anatomy test on Friday?
No, Wednesday, I think.
Jay, if you pass that around after you,
Yeah.
thank you.
Go for it, the new test.
Answer key is posted.
So.